Okay, here goes. We have learned how to factorize quadratics where a is equal to 1, this leading term. So we've got an x squared in there. We've solved quadratics. We've even formed and then solved quadratics like that. We've then factorized quadratics where a is not equal to 1, things like 2x squared plus such and such. And then we've looked at it where it's even more complicated and it might be 8x squared plus such and such. And you have to figure out, is it 4x and 2x or x and 8x? Today, we just finish things off by solving and forming quadratics where a is not equal to 1. I hope you're up for it. So, first things first, let's get into how we solve these. It's a very similar process to what we've previously looked at. First thing to say is that sometimes they don't look like they're quadratics, okay? You get an equation like this here, you might think, what on earth is going on? But we can expand the bracket, and then suddenly we see that it is none other than a quadratic. 3x squared plus 6x equals 5 minus 8x. That x squared comes out. That is the highest order term. There's no x cubed, but there's an x squared we've got to deal with. We've learned how to solve these. We get it all the terms on one side. So I'm going to add 8x and I'm going to minus 5. And it's equal to 0. Because now we've got this method. We will learn other methods, but we've got a method called factorization, where we create a double bracket, still equal to 0, and then it's got to be 3x and x here. That's the only combination that could work. And we try some things out. It's either going to be 5 and 1 or 1 and 5. I've just gone with 5 and 1, so I get 3x and I get 5x. So no, that's not going to work. It's going to be the other way around, 1 and 5. I can see that. I can see the 15x. I probably should have gone for that straight away. 15x and x. Right, if I make this a minus x, so I make this a minus 1, then I am sorted. And it's going to be 3x minus 1, x plus 5. We factorized it. Here's the new bit. It's not really new because we've looked at it before when we've just got x's here. Previously, sometimes you just like flip the signs around. You've got to be a bit more careful here because there's a 3x here. So I'm going to go for it in full. It's going to be 3x minus 1 equals 0, or x plus 5 equals 0. One of those must be equal to 0 for this to work. And then I can add 1 and divide by 3. So x is going to be a third, or I get my minus 5 here. So the new bit really is what you do when you've got a number in front. You just have to solve that equation equal to 0. And you do flip the sign, essentially, to make it a 1, and then you divide by whatever's in front of the x. I mean, we're just solving a linear equation. And that's it. We've not formed any yet, but we've solved quadratics where a is not equal to 1. So try a few yourselves. Yeah, they're not in the right form to start with. You're going to have, and some of them are in terms of y. That's still okay. You just solve for y. Can you rearrange and solve them? Go for it. So this first one, you get this when you've brought it on one side. Makes sense to make it 2y squared. Don't make it like minus 2y squared. If you get minus 2y squared, move it all to the other side. Factorizes like such, and then we solve it so that we flip the sign around and we divide by the 2, or you can write the equation down, 2y minus 3 equals 0, and solve that. Next one, should get this after you've expanded the bracket, brought the terms over, factorizes, solved. And finally, we've got a double bracket to expand. Yeah, so we have to get it equal to 0 for our factorization to work. We can't just say x is minus 2. No, because it's not equal to 0. So we have to do expand it and simplify it and bring it over to one side. Then it factorizes like this and solves like this. Okay, that was quite well. Was that quick? It seemed quite quick, but hopefully pause the video and try all of those. Hopefully your solving is in a good place because we are stepping it up now. All right, so we've got a problem here that we need to try and solve. We've got a patio, it's 4 by 5 meters, this inside bit here. We've got 10 meters squared of turf, and we want to use it to make a border around the patio that's the same width all the way around. We don't know what that width is, that's what we want to find. So we're going to label it X. Who knew that we could do this using quadratics? But next time you are putting turf around a patio, think about using this knowledge. Okay, and we're trying to write an equation down for the area of the grass border. Well, this is going to be the area of the whole thing, the whole rectangle, minus this middle bit, and that's going to equal 10. So we can create an equation. So it's going to be base times height to start with. We've got x here and x here. This is part A. This is 2x, and then I'm going to be adding 5. That's my base. And then I'm going to times by my height, which is 2x plus 4. Now, that is the whole area, so I'm going to need to minus the blue bit, minus 20. And that is going to equal 10. And we've constructed an equation. You can see the quadratic in there. Next thing, we expand the bracket. 4x squared plus 8x. I'm kind of doing this without, let me put the crab clause in, just in case you've forgotten this. Plus 10x plus 20 minus 20 equals 10. These are going to cancel. I'm going to be left with 4x squared plus 18x minus 10 equals 0. Now, is that an equation? It is. You could leave the answer like that. Actually, before you try and factorize it, you should always look for common factors in equations, and there's a common factor of 2 going on here. So I would write my final answer actually as 2x squared. I would always try and simplify an equation. I've not solved it, I'm just 2x squared, just writing it more simply, plus 9x minus 5 equals 0. And that is going to be the answer for part A. And now we're ready to solve it. Jerry uses all her turf solve to find x. We're back to factorizing. It's got to be 2x and x. It's got to be 1 and 5 or 5 and 1. It's going to be, the 5's going to be here to give me the 10, and I can see I'm getting the 1, so I did this around 10x and x. We want that to be a minus, so that's going to be a minus, so minus 1 and plus 5. Don't forget the thing is equal to 0, so I get x equals a half. I'm flipping straight to it now. I just take the 1 and divide by 2. You can put the extra step in if you want, or minus 5. Now remember, we've got turf, so even though that minus 5 solves the quadratic, it does not solve a physical problem. We can't have negative width for our turf, so we're going to reject that. And the width, the width of the turf is going to be 0.5 meters. I'm just going to write that down as a decimal at the end. We formed and solved a quadratic. Right, over to you then. You're going to see lots of scenarios now. Just be careful, form a quadratic, use your knowledge of the geometry or whatever you're looking at in the problem, create an equation and then solve it. Work through each one. I will post up a handout of all the questions, so you can go one at a time by watching the videos, or you can just do them all and then check them. I'm going to put the answers up. Okay, so please pause the video, try these out. This first question is going to talk for a very similar situation to the garden problem. Okay, so we can, again, we can cancel it down. Actually, it just cancels down to 1 with an x squared in. So it's got to be 2 meters once we solve it. How about this one? So these show that questions. Even if you can't do the show that bit, you can still then solve it. You can do, this bit, but try and learn how to show that. You can do it a few ways actually, I would say. They've just shown one way here, but you could split the compound area this way, or you could split it this way, or actually you could do this and then minus this bit here. So there's lots of ways. You might not have done it the way the answers have done. However, you must get the same answer in all cases. So actually, it doesn't really say in the question, but I would reject the minus 7.5. So actually, x is just equal to 5. Reject. Wow, it's hard to say actually, because part B doesn't actually relate it to the original problem. So technically, both solutions are good. I'm just saying if you actually relate it to the shape, you should reject the negative. Very similar one here. Find the perimeter of the shape. Well, here are two ways that you could do it. Similarly, like splitting it different ways again, and you should get x equals 2. Perimeter is 40. Back to right-angled triangles. Can you show that's true and then find the value of x? This is Pythagoras' theorem, but this time with a 2x plus 4 and a 4x minus 3 in there. Yeah, you've got a fair bit of manipulating to do. You'll get 11x squared minus 42x minus 8 equals 0, as you need to, and then you'll factorize that. They've not done the factorization. Let's just have a go. It's got to be 11x and x. Sorry, my pen stopped working there. Bit of lag going on. Okay, so right, for this to work, I've got to think about this. I'm not going to put a 1 there and an 8 there. That's clearly not going to work. It's probably going to be a 4 and a 2. So I think if I put 4 there, I'll get 44x, and I'm close to it. And then the 2 here will work. So I'm going to need 11x minus 4. This is the sort of way you can do it without, working down the page, equal to 0. And then you see that x could be minus 2 over 11, but we reject, or the 4 in the question. And that one's okay. You could be asked for the perimeter and so forth. So actually what we end up with is a 5, 12, 13 triangle. This is a Pythagorean triple, 5, 12, 13. Back to surface area of cuboids. Calculate the volume. Construct a quadratic. It's going to be a quadratic by considering every single face of the cuboid. We can work out, so two lots of x minus 1. That's come from finding the right-hand side and the left-hand side. Two lots of x times 3x minus 1. That's going to come from the top. No, wait, the front and the back. And then the top is going to be these two multiplied together, but we've got two lots of them. Add them all together, set it equal to 92. We've got a quadratic. Cancel it down as best as you can to 7x squared, and then it's not nice, but actually, there's not two options for the 7x and the x. That's the only option, so then you just got to make it work with here. X is going to be 3, from which you get the volume. Oh, the return of fractional equations. Cross multiply, first thing, and then actually it's not that bad. It's just that first step. Ratios. There's different ways you can do this. One way is this one. You can do the first one divided by the second one is the first one divided by the second one. I would probably be more tempted to do x squared over 1 equals 3x plus 5 over 2. Basically, this is working out the scale factor. What do I times by to go this way or the other way? It's like 2 to 4 is 4 to 8. So 4 over 2 is equal to 8 over 4. It's the same here. X squared over 1 or 2 over 4 is the same as 4 over 8. And then actually this is a bit easier to solve. But you could do it this way. You get the same thing. Two solutions here. It's absolutely fine to get two solutions for this ratio question. Right, that's it actually, except these super challenges. These are going beyond GCSE, let's be honest. But try them out. I'm going to show you the answers for these two. They are a little bit trickier again. You might think, where's the quadratic? But we'll find out. Right, here are the answers. I don't know if you managed to get it, so you should get t is 7 and x is 0 or 3. I'm going to go through these. Okay, when you have a root, maybe you've never solved equations like this. You tend to solve ones like this at A level actually, but all we do is we square both sides. If you got the square root, we square both sides. We just do the opposite. We need to be a bit careful here though, because if I square both sides, I get like a double bracket going on, and I'm gonna get more surds. So before I square both sides here, this is a little trick for these sorts of questions. Just get the root by itself on the left hand side and minus that 3 over. So it's going to be 2t minus 2. I could divide by 4, but then I'm going to have a fraction. But actually, it would probably make sense to divide by 2 to simplify it slightly. If you don't see to do that, that's okay. But now I'm going to square both sides. And when I square both sides, I square each term individually. So I'm going to get 4 times t plus 2 equals t minus 1 squared. And that's where I get the quadratic coming on. This is now much nicer. So expand the bracket, 4t plus 8 is going to be t squared minus 2t plus 1. So t squared minus 6t minus 7 equals 0. And now that will factorize t minus 7, t plus 1 equals 0, t equals 7, or minus 1. However, is that okay? The minus 1, right, actually, here's a little crucial point. These might look like both solutions, but when you square something, you need to be a little bit careful. For example, if I have x equals 2 as a solution, if I square it, then I still have 2 as a solution, but I introduce a new solution of minus 2. When you square things, you create spurious solutions, like ones that don't actually exist. They solve your final equation, but not the original one. So let's put 7 back into the equation. 7 plus 2 is 9. The square root of 9 is 3. So I get 12 plus 3. I get 15. 2 times 7 is 14 plus 1. I get 15. So this is fine. However, when I do the minus 1, I'm going to get a negative on the right hand side. That's the main issue, and there's no way that I can get a negative on the left hand side. If you substitute it in, it won't work. So I'm not rejecting it on physical grounds, I'm rejecting it on the fact that I've checked it and it doesn't work. When I've squared over here, I've introduced a solution that shouldn't be. Okay, minus 1 is a solution to this equation, but not to the one before it. That is a subtle but important point, and I hope it makes sense. That's almost certainly the first time you've ever seen a spurious solution. The next one. This one is actually, there's no spurious solutions, but it's more challenging for sure, because now we've got a square root on both sides, and I've managed to run out of space, so I'm just going to have to delete that and start here. Okay, well done if you made it to this, by the way, and well done if you got it wrong, but you're like persevering and you want to know why you got it wrong. That is fantastic. Okay, for this sort of equation, what do? We can't just have a root on one side and then square it. We've actually got 2 roots. Well, we're going to have to just square it. We're going to get 3x plus 16. Yep, that's fair enough. But now I'm actually going to I'm going to write it out in full. I'm going to get 3 plus x plus 1 squared, which I can write as a double bracket. And I'm going to have to expand that. I'm going to get 9 plus 3 lots of root x plus 1, but plus another 3 lots, so 6x plus 1 plus x plus 1 when I expand this one. So I hope you're okay with that. I haven't done it too fast. I've still got a root in there. That is not very nice. However, I've nearly turned it into the problem we did previously, because I've just got one root, and that is great news, because I can basically now put all the other terms on the other side. So I can minus x from both sides. It's going to be 2x. I can minus 10 from both sides. It's going to be 6, and that is equal to 6 lots of x plus 1. And I would say let's divide through by 2 before we do anything else, just to make the numbers nicer. We've then turned it into the same thing as before, so I'm going to square both sides again. Okay, squaring this side gives me x squared plus 6x plus 9, double bracket, remember? X plus 3 times x plus 3. And then I square this term, and I square this term. Hopefully I haven't gone too fast. I'm like assuming your knowledge of that. X squared plus 6x plus 9 equals 9x plus 9. This is good news actually, because these just cancel out. And I'm going to have x squared minus 3x Let's try that again. X squared minus 3x is equal to 0. Factorize it. X minus 3 equals 0. X equals 0 or 3. We need to check though whether there are these are spurious solutions. Put in the 0, we're going to get root 16, which is 4. And 3 plus root 1, that's 1, so 4 equals 4. That one's okay. And the 3, 9 plus 16, 25. We're going to get root 25, which is 5. 3 plus 1 is 4. Rooted is 2. We get 5 there, so these are both correct. Fantastic. Okay, they won't be this hard at GCSE, let me just point that out. But actually, they're not generally even that hard at A level. They go beyond it. But at the same, or you just don't really talk about this sort of question in A level. So if you've got it right, give yourself a little pat on the back. Hopefully you just enjoyed solving some equations. The main thing, if I'm going to summarize this lesson, is all the way back up here. We can now solve quadratics where a is not equal to 1, and we can form them as well. Brilliant. What a great topic. We're going to learn some other methods for solving quadratics. That's coming up next.